Hi guys, BuildZoid here, and today we're going to be taking a look at the sort of final incarnation of the 1080 Ti BuildZoid edition. Um, it's horrific, isn't it? It's very orange. Now then, the orange is very simple. That's just orange Plastidip, and it's all over the card to basically prevent water from getting under things like the memory chips, the GPU core, um, all of the VRM components. Yeah, basically it's just there to prevent water from destroying the card. So yeah, and you could definitely use conformal coat to do this. You could use some people use kneaded eraser, um, liquid electrical tape. There's tons of options, really. There's tons of options for how you can do this. I've actually gotten away with running GPUs with zero actual insulation and just wrapping everything with like an insane amount of blue shop towel. That also works because basically, if you can set up an air barrier, so as long as no fresh air can get to the PCB, there's no air to dump more humidity onto it, right? Because if you trap the air against the card, once that all condenses, which if you have a small volume of air trapped against the surface of the card, then there's not really that much water in that. Once all of that condenses, you have a dry environment around the card as long as no more fresh air can access it. So you can sometimes get away with just like insane amounts of blue shop towel and basically mummifying the card. And then you can kind of run without any real insulation, though I really wouldn't recommend that because if you have a very small mistake, you can end up in a really bad situation. So this is a much better way of running things. If you watch the live stream, then I actually ran into an issue where the HDMI connector was becoming a puddle. And so at one point in the live stream, the HDMI port just completely stopped working because it had so much water in it, you couldn't pass data over it anymore. So the monitor dropped out. The card was fine. The card still works, but the HDMI was gone. But when I did another session with the card. So on the live stream, I was just benching Firestrike, and on my own time, I did Firestrike. I did a Firestrike Extreme score, and when I was benching on my own, I actually figured out a way to deal with the HDMI port problem. What I did was I wrapped the entire like HDMI port section with a ton of blue shop towel, and basically that did what I said with the blue shop towel covering the rest of the car. If you wanted to, blue shop towel the crap out of your PCB, you get a insulation where basically as long as any air doesn't get under it, you're good. So I did that for the HDMI cable, and that worked actually great. I finished my entire 30-liter DWAR on that insulated HDMI cable. So, yeah, that worked really, really well. And when I pulled the card apart, that cable was dry. It was very cold to the touch, but it was dry. So that worked perfectly. So that's definitely one valid way of doing it without like worrying about heating elements or something like that. Just wrap the HDMI port in enough towels to prevent any water from getting on there. Um, so that kind of covers the orange Plastidip here. I did say in the last video that I wanted to Plastidip the VRM, but you can kind of tell that there's no Plastidip down there, and there's a simple reason for that. The VRM on this card originally was loaded, like it came with thermal pads, and those stock thermal pads are normally pretty low quality, and so they leak a huge amount of silicone oil, which isn't a problem. That's fine. It just means like eventually, that's how they're supposed to work. But it's annoying because you get silicone oil everywhere. And the thing is, silicone oil basically acts like a mold release for Plastidip. So if I covered it up in Plastidip, it would peel right off. Because everything was soaked in silicone oil. Like that PCB is still loaded with silicone oil. You can still, like I tried, cleaning it with alcohol, a lot of alcohol, and yeah, it didn't go anywhere. Basically, if you just let the card sit for a while, you can see it seeping back out of the PCB. So yeah, I didn't Plastidip that area. But basically the theory was, well, there's a thermal pad on top of that VRM. Hopefully too much air can't get under that. Luckily, the VRM actually produces enough heat on its own while running, and also with the fan blowing onto the VRM heatsink. Like, this is the funny thing, that VRM heatsink, if the VRM temperature starts dropping below ambient, then this VRM heatsink is actually bringing the VRM temperature up. instead of down, because it'll, like, if there's heat in the VRM, it'll pull heat out of it and put it into the ambient room air. If there's more heat in the ambient air temperature than inside the actual VRM, it'll do the exact opposite and dump heat into it. So this area of the board was actually, thermally, it was fine. It wasn't having any massive issues. It was really, like, it was not running hot, but it also wasn't running so cold that it was freezing over. So there wasn't actually any water issues like I was really worried about. And part of that might also be because I disabled the power efficiency stuff and had the VRM running at 600 kilohertz. So VRM efficiency on this card is absolutely shot because it doesn't phase shed. Well, there's the 600 kilohertz switch, which basically just makes the VRM run at maximum switching frequency. And yeah, so that's the VRM heatsink, and let's just take that off. So that heatsink is off a Sabertooth 990FX motherboard from Asus. So, and I use it on a bunch of GPUs because it's just so it's so long that it just clips right over any VRM that's a straight line. And I've been actually thinking it'd be really cool if some like heatsink manufacturer designed something like this that was actually like intended for this purpose. Because the problem with this thing, right, is you can't actually put a heatsink over it. It's too damn tall. But if somebody wanted to just make a VRM heatsink, which is literally just way longer than the GPU and then has another plate on the back that sort of sandwiches the PCB in between the two, it's an option for any card that has a straight line VRM. Like, as long as none of the components go, out of the line of where the VRM heatsink goes, you're gold. And yeah, so it works really well for this card. I have a couple other cards where it works. I ran this on the HD7950 I have. So yeah, I really like this heatsink as a sort of like option heatsink for any GPU I come across. So there we go. Get that off without breaking all the cables. There's the thermal pad on that. That's a Thermal Grizzly thermal pad. And I actually don't like these thermal pads. They're really, really hard. Like, you can see that basically there's very little indentation from all of the VRM components. So these are actually kind of terrible in terms of, like, compressive capabilities. They really don't compress, which is a problem because if you don't get your clearance of this thermal pad versus, like, if you have a GPU which needs a thermal pad that's like a very, very specific thickness, this is so hard that it'll warp the PCB when you tighten down the heat sinks, which is, of course, bad for the health of the PCB and all the components on it. So that's kind of that. Blue shop towel on the back just to sort of prevent it from crushing any components on the back of the card. And yes, I could not stop myself. The card already looks horrendous with all the orange, so I went a step further. And this is true. This thing does run full pot, which is really, really nice. It's very easy to run because of that. 600, 300 kilohertz switch labeled. 600 kilohertz actually works really, really good for benchmarking. Like, it gives it, on LN2, I want to say it gives you like 20, 30 megahertz for free, basically. Well, it sends your VRM efficiency to hell, but like, you don't need to raise the voltage any higher. You just flick that switch and bam, something that was previously almost stable suddenly is fully stable, which is really, really neat. So basically, after I figured that out, it was just like, yeah, we're running 600 kilohertz all day. What else is there? Right, the temperature probe, this works great. You just need to, like, you need to be very methodical? Yes, methodical. That's the word. Methodical with using it. Because if you just, like, basically you won't notice, like, the problem is the temperature delta that you get while if you just run the benchmark, at different voltages, you actually get completely different temperature deltas because the power consumption of the card just gets absolutely ridiculous as you go up and up. So, for example, at, like, stock, this card is like 250, 240 watts. And keep in mind that this card doesn't actually pull any of its power through the PCIe connector. Like, that connector's lopped off. Like, it's missing the last 3 or 4 pins. So it doesn't get any of its 12 volts power from the PCIe. And at stock, this entire card in its current condition without at 300 kilohertz pulls about 250 watts. Now on LN2, if you watch the actual live stream if you watch it on Twitch right now, I'll eventually upload it to YouTube. Well, eventually make it public on YouTube because it's already uploaded. I'm just not sharing it yet. I like to stockpile live streams for when I can't make videos. So, if you watch the live stream, this thing actually hits something like 66 amps on the 12 volts. The 8-pin and the 6-pin. So yeah, we're going way out of spec on those two connectors right there. Well, it's actually not that much of that terrible an overload. I mean, technically speaking, you don't really want to push more than 20 amps through the 6-pin and more than, how many is it? 30 through the 8, but hey, that's 50 amps total and 66 amps is only exceeding that spec by what? Like, almost not even 50%, so we're fine. We're fine. Not a problem. Connectors didn't melt, but at 1.6 volt, like at one point, it wasn't even like straight 1.6, it was like 1.58 or 1.59. This thing pulls an insane amount of power, and the end result is that basically your back of core delta gets ridiculous. Like this thing while running Firestrike, even with perfect thermal paste condition and everything, is easily pinging minus 50, while the LN2 pot is at full pot. So, like, you're loaded up on LN2, the temperature sensor at the base of the LN2 pot is telling you that you're at, like, minus 188, right? Minus 188 on the LN2 pot. And this thing is telling you that the back of the card is at minus 50. And that's just insane to think about. Like, because what you have to understand, right, across this distance here, right, this distance, the temperature difference is minus 50, minus 188, right? Like, that's insane. That's absolutely insane. And basically because of that, you have to really, like, what I ended up doing, which I did off stream, was I ran Firestrike and I just worked the LN2 pot temperature down, keeping a very close eye on the temperature of the probe on the back. Because if you do that, you can actually catch things like thermal paste crackage or thermal paste degradation really, really quickly. And it actually shows some pretty major interesting things about the thermal pastes themselves as well. So it is very, very useful, but you need to run it under a constant load, because this probe will fly up and down if you cycle the load, because it's really, really delayed in terms of its response relative to the actual die. So you really, really need to sort of, like, that's basically why I ended up running Firestrike on loop and working the temperature down and just watching this temperature probe's response against the temperature probe in the LN2 pot. So if I saw that the temperature in the LN2 pot came down by 20 degrees and the probe started going up by 20, the thermal paste just cracked. But if you actually went all the way to full pot and then started a benchmark, you wouldn't actually notice, because this thing is so slow to sort of respond that you wouldn't notice the difference. Like, you wouldn't see that there's a problem, because it still wouldn't go up so positive that you would go, oh yeah, we've definitely done something wrong. So it is helpful. It's just fiddly to work with. But I definitely think this is a cool addition to have on a card, and I'm going to keep doing this, because at this point, it's just like the more data I can get on what kind of temperatures on the back of the core you should be seeing, the more useful this becomes over time. Because yeah, I've so far I've only done this on 2 cards, and now it's just like I'm gonna buy like 20 odd K type thermocouples, and I'm just gonna run it on everything because it's that helpful. Yeah. Also, I'm gonna say about the 600 kilohertz switch, if you have a 1080 Ti like a Strix or a Gaming X from MSI or a Amp Extreme from Zotac, or really any 1080 Ti using the UP9511 voltage controller, get yourself a 600 kilohertz mode. Totally get yourself 600 kilohertz. This is so useful. If you're going to be benching LN2 or even dry ice, get 600 kilohertz. It's so good. Like, free megahertz. A couple free megahertz by just changing a resistance. Basically, 300 kilohertz is 33 or 32 kilo ohms from program 6 pin to ground. 600 kilohertz is 16 kilo ohms. So you just kind of do that and you're good. And, you know, you're good to go. And yeah, that is awesome. I love that. Other issues to consider with a 1080 Ti. So since this runs at full pot and there's no actual no real heat generating components in this area of the card, what you're going to end up with is an absolute flood in the HDMI DisplayPort connector area. And you can't really just plasti dip over these because they're connectors, so then they're not going to connect to anything. Same as you can't plasti dip over the PCIe slot. So, you know, that's kind of an issue. And on the live stream, I actually ran into that where basically after, I think, roughly 2 hours of running at full pot, well, it might not have even been 2 hours, but basically after running for some time, this HDMI connector became such a flood of water that it just stopped working. Completely just stopped working. And there's actually a way to get around that doesn't involve pointing a hairdryer or a heat gun or sticking a heating element into this area. And that trick is that you wrap the HDMI, like you completely load this entire area with blue shop towel, and you wrap the HDMI connector in blue shop towel. And the reason you do that is basically because if there's no fresh air, because like the air, you know, in the room has a certain amount of humidity in it, right? And if you trap that air around the connector and around the PCB, which is why, like, I've gotten away with running GPUs with no plasti dip whatsoever or no proper insulation and just wrapping them with tons and tons of blue shop towel. The idea behind that is if you trap the air against the PCB and don't allow any new air to enter, once the humidity in the air that you trapped basically condenses, there's no more humidity to condense, and the little air that you've trapped against the PCB really doesn't contain that much water. So you can basically run really, really low, like you can get away with that. I still wouldn't recommend that you try to do that for your whole card, just because it tends to be really unreliable. And if you have like a hole in your shop towel or anything like that, then you're just going to be screwed in an hour or two. But for the HDMI connector, it worked really, really well. Basically, this entire area was completely wrapped up, so you couldn't actually see the connector. I had a paper clip holding the actual towel onto the connector itself, like on the other side of the card. And basically, at the end of my multiple hour session, I think I started at like 10 in the evening, like my off-stream session. I started at like 10 in the evening and finished at like 2 or 3 in the morning. So in that session, like at the end of that session, the only, like, when I went to take the card apart, the HDMI connector was cold, but it was dry. Like, it was definitely very, very cold. It was definitely cold enough to become a puddle, but it was completely dry. So that worked really, really well. So just wrap that in as much blue shop towel as possible, and that works really, really well. So I guess at this point I've kind of said everything there is to say about the card. You know, yeah, it was, so, you know, it was max power consumption was probably around 800 watts average. I think actual useful power consumption was around 700. Like, what I could actually run benchmarks at was probably around 700. If I wanted to at high enough voltage, yeah, I would pull 800 watts, but at that point the card would actually start to thermally roll over. I ran with this thermal paste. I can very strongly recommend this thermal paste if you're starting out on LN2, or you don't have a lot of LN2 and you really don't want to waste thermal paste, because this stuff is super reliable. Like, it seems like I've not had this crack yet. On the flip side to that, it doesn't seem to be particularly thermally conductive to start with. So when I was testing, because I tested both, I tested both the Cryonaut and the KPX, and the Cryonaut, like, let's just put it this way. When I was off-stream testing the Cryonaut, this cracked 3 times in like an hour. Part of that might have been because I was on the Raptor 4 and I was using the sliding mounting hardware, so it wasn't exactly the most reliable mounting system. And I might have screwed up the application of this stuff. But this cracks a lot. And if you screw up the application, it just always cracks. This, on the other hand, I've not had it crack at all. I don't think I've had it crack a single time, which is crazy. On the flip side, when I was testing the Cryonaut, the rear probe was reading much, much lower temperatures than what I was getting with the KPX. But, you know, the thing is, yeah, so you can get better thermal transfer out of Cryonaut. The problem is, if your Cryonaut cracks, your thermal transfer is infinitely worse than, you know, this stuff. So for that reason, I think this is a better testing paste. Like this is like what I would go for if I just wanted to bench without a care in a world. This is great. It works really, really good. It's really, really stable. But thermally, I think it might be inferior. I still need to test because the problem is I never actually got to full pot with the Cryonaut, so I don't have I don't have data for what this would do once you're at minus 190. But this at minus 190 was basically showing the same temperatures that this would be doing at like minus 130. Like the temperature delta on this was much lower than with that. But once this cracks, your temperature delta goes straight to hell. So, you know, that's kind of interesting. And yeah, I really wish I hadn't run out of LN2 because now I want to retest these again. Because it's just like I want to figure out if this could go faster. Like this can probably go faster if I run this, because the card is extremely temperature limited as far as I'm concerned. But this is so much more reliable. I rather like this. So yeah. So now I think I've covered every... Oh, no, I haven't covered the LN2 pot. So this also way more reliable. Like this 8-point mounting hardware is, it works really well. But the problem is I didn't do an A/B test. So I've not run this plus this on here. And I've not run, like I've run this pairing and I've run the Cryonaut only with the Raptor 4. And the Raptor 4 has a 4-point mounting system. So I'm not sure if, so I'm not 100% certain that it's the KPX or the Cryonaut, or if it's the 8-point mounting system making all of the difference. But from talking to other people, they seem to notice the same thing where KPX doesn't crack as much as Cryonaut does. Cryonaut runs better. Like, Cryonaut, when it doesn't fail on you, works better, though. So... This is kind of like an Asus motherboard. If it doesn't break your CPU, it's really, really good. So, yeah, and by that I'm referring to like Asus motherboards have some really weird glitches that you can run into sometimes on liquid nitrogen, which insta-kill CPUs. It's not like a concern for the average user. It's just sometimes with an Asus motherboard you're on LN2 and they'll throw you a 0-0. And sometimes that means the motherboard randomly decided to give your CPU 2 volts. And sometimes that means your CPU just died because you're an idiot. But, yeah, anyway. So I really do want to retest. I've just run out of liquid nitrogen at this point. But this pairing definitely works really, really well. I'm not sure if this could work better, but what I do know is this plus the Raptor was a disaster. So that's worth noting. And, yeah, so, card, you know, ran good, ran good. Let's take a look at the scores at last, but this is the, you know, this is kind of what the hardware setup was. Tech 9 Fat from Kingpin Cooling, 8-point mounting bracket, KPX, VR I'm running at 600 kilohertz, 1.55 volts on the core. Well, 1.55 to 1.57. I was experimenting with higher clock speeds, and I could kind of do them at higher voltage, but there was issues with that. So then, let's take a look at scores. Scores. So this is the Firestrike Extreme score I did. As you can see, it's at 2455. Now, there's a caveat to that 2455 clock speed. So the thing about the 1080 Ti is... if you just run Firestrike on loop and you start raising the clock speed with, like, you have Firestrike on loop, windowed, and you start raising the clock speed while it's running in the background, you can actually raise the clock speed really high. Like, I was doing 2480 for Firestrike. The funny thing is, if you try to actually run the benchmark, right, instead of running looped Firestrike, if you just try to run the benchmark, in the first 3 seconds, it'll crash. Okay, and I couldn't really find a way around that. So what I ended up doing eventually was screwing around with like hotkeys and for precision X, so that basically I could go into the benchmark at 2404 because 2404 wouldn't crash. Like that was the maximum clock speed that would finish the whole benchmark, but but wasn't necessarily the fastest. And then once I was running for Firestrike Extreme at 1.56 volts, I could go to 2455 and run the remaining, the rest of the GPU test at 2455. Once the test finished, I'd go back down to 2404. Once test 2 would start, I'd wait 3 seconds, run 2455, and basically do it like that. And I still need to play with that. It looked like it was helping for a bit, and then I changed some settings in the drivers, and then the score went to hell, and yeah, I'm not very good at benchmarking NVIDIA cards, but that seems to be that seems to be something I definitely could mess around with, and it could work, because it did seem to be helping the FPS a bit. The thing is, I don't know what happened. The end results weren't really that great, but for Firestrike, I ended up 19th using a GTX 1080 Ti. I think I'm basically at the bottom of the stack for LN2 1080 Ti's. Part of that's also because I'm on a 7940X. My combined score is crap because I don't know anything about combined. The physics score right there is not as high as it could be. It's actually about 1,000 or no, it's like 1,500 points low for the settings that I'm running on the CPU. And you'll see that because Firestrike Extreme uses the same physics test as Firestrike. If you look at Firestrike here, you can see, yeah, like I'm getting 35,000 points physics there. The problem is the only way to get that high physics score is to set, is process lasso and running so process lasso for real-time priority, and you still need to rerun the benchmark a couple times. And I'm just going to blame Windows 10 for that because Windows 10 just sucks and you really shouldn't use it for benchmarking, but I'm too lazy to set up a proper operating system. And quite frankly, I'm just more interested in pushing the card around than messing around with Windows just to get 100 extra points or 500 extra points in freaking physics. End result being that the overall score kind of sucks, but I only have myself to blame for that. Now, this score is actually off of the live stream, and this is at 2404. And you can see I'm getting like 36,000 points GPU score. I actually managed to improve on that. Once I figured out the thing with the hotkeys for Precision X, I managed to do like 36,700 at 2480. Actually, no, that was at 2455. So yeah, I was doing quite a, like I could have probably, if I hadn't screwed up the operating system, I could have probably gotten 37,000 because eventually I was doing GT1, so graphics test 1. I was passing graphics test 1 at like 2480 core clock, and I was doing graphics test 2 at 2500 actually, 2505 for graphics test 2. Because graphics test 2 is actually very memory heavy, but it's not that core heavy, whereas GT1 is very core heavy and less memory heavy. So like I had it dialed into the point where I was actually running GT1 with more memory clock, less core clock than I was running GT2 with lower memory clock, higher core clock, just sort of to play to the strengths of the tests. And the thing is, but I screwed up the driver settings. So even with all of that, like even with the higher clock speeds, I wasn't actually scoring any higher than this. Though when I first started messing around with the hotkey stuff, it was actually scoring better. Like I was doing 36,600, 36,700 at 2455 for both GT1 and 2 using the hotkey trick. But then I did something to the drivers, and I didn't realize that it probably was me screwing with the drivers until I ran out of LN2, and I'm an idiot. Yeah, I know. So that's kind of what happened. Yeah, I'm really disappointed in myself, to be completely honest. I really wish, like, if the LN2 wasn't a shortage, being an idiot wouldn't be such a big problem. Because it's just like, oh, so you were an idiot. You can just use another 30 liters of LN2 to figure out how to get it to score good again. But, or if it even worked. But basically, So this is the score off of the live stream, which is a 2404, which is the maximum clock that the card just passes naturally. The cool thing is with the KPX and the Tech 9 with the 8-point mounting system, like I can run 2404. Like I could probably go, if I still had liquid nitrogen, I could rebuild the card right now, mount it up, pull it down to full pot, and bench 2404 like that. It's that easy, which is really, really neat in my opinion. And also for the memory clock, so you can see I'm running like 1583 memory clock. That was with 1.51 to 1.52 volts on the memory. So GDDR5X scales from memory voltage, which if you've read any of the 1080 Ti extreme overclocking guides, they say as much. And the GPU core, I've seen a lot of people talk about really low voltages on 1080 Ti's. I have no idea what that's about. My card scaled all the way to like 1.58. Like when I was doing those 2480, 2505 passes for GT1 and 2, for those clocks, like if I came in with less voltage, they would actually straight up crash. So yeah, like these cards need a lot of voltage, and I'm not sure if maybe some people are having like trouble with load line calibration, because I have the LLC on this card basically disabled. Whereas disabled as it can be because it's set by a couple milliohm resistor, so even a dead short circuit isn't really that low. But yeah, like my card was drooping like 20 millivolts going from idle to full load. And full load, we're talking, 800 watts of GPU power consumption. So pretty crazy card, pretty fun to benchmark actually. Especially because it's full pot, so it's really, really easy. Like once you get it to full pot, you don't really have to worry about anything except maybe the thermal paste cracking. But the KPX really doesn't do that. I don't know how it would be with the Cryonaut, because the Cryonaut always failed for me at minus 130. Like I couldn't get below minus 130 without having it fail. So that might have been my application method, because yeah, like Cryonaut's kind of picky. And also I've noticed that there's definitely variance batch to batch. Like one of my batches was much thicker than one of the next batches I had. Then I have one batch which was like really, really grainy and abrasive. And then this newest batch is like really, really smooth and actually seems way more liquid than my last batch. So it's kind of all over the place. And that's actually kind of annoying. So yeah. Anyway, back to the card. Because I think you're all kind of tired of looking at the Firestrike score. But yeah, definitely interesting to benchmark. I really want to run it more. I've still not modded the PLL circuit. I think I might, just because like this is definitely, as far as the core voltage goes, this is maxed out. The only things I can see helping this card go faster are lower operating temperature, which is why I still need to play with this, and that voltage right there, PLL. Like this might be the key to the next 50 to 100 megahertz. Maybe. I don't know. Maybe the card just sucks. Maybe this doesn't do anything and I'm wasting my time. That's kind of the unfortunate thing. Like I really wish I had more 1080 Ti's on hand. Also, this card sucked on air, so it's like, I wonder if maybe like a better, because if you look at 1080 Ti's, like even on just ambient cooling, you can see something like 100 megahertz of variance, right? Like there's cards that do 2150, and actually EVGA with their Kingpin editions, right? Those are pre-binned, and actually no, they are straight up pre-binned. They guarantee that the Kingpin edition cards do at least 2050 core clock, which really isn't that high, but they guarantee that 2050. This card doesn't do 2050. So like that already is like, you know what? Maybe I don't suck. Maybe the card does, because 100 megahertz variance, there's a good chance this card's just bad, and it's not my fault. And this really is the absolute limit of what the card will do. Though I still think, no, if it could run colder, I think it would go faster. Like, it would definitely go faster. Like, liquid helium or just getting this stuff to work, I could totally see this going another 10, 20 megahertz, because it's so temperature sensitive. And at that point, you could probably bump up the voltage again. And then it would go fast like that. That would, like, for the core, and that would go faster. That would speed it up a bit again as well. So yeah, and you might be wondering, well, BuildZoid, with so much crazy power consumption was the VRM getting very hot. No, giant freaking VRM heatsink kind of took care of that problem, and there was a fan blowing at it. So really, the VRM basically stayed pegged to like slightly above ambient or slightly below ambient, depending on how long the card was sitting at idle. Yeah, it was very, very, like, I enjoyed it. This video is almost as long as the bloody live stream, but there's just so much to talk about. This is kind of why I love this is why I love LN2 benchmarking. It's just like, it looks really simple on the surface, but, well, it to some extent it is, but there's quite a bit of depth that you can go into unless you buy like a Kingpin card, which like you wouldn't need a 600 kilohertz switch on a Kingpin card. That card already runs at probably maximum VRM. I actually wonder what VRM switching frequency they run at. You can probably change it though, on that card, maybe. Oh, well, no, definitely. If you had an I do wonder about that. I wonder what, like, I really wonder, now I'm really wondering what switching frequency they run at. I know on some of the other cards it was possible, so it probably was possible on that one as well. But, yeah. Fun card to benchmark. I don't want to let it go, because I still want to bench this with the CPU, like, I really want to bench with the CPU subambient. And I'm actually thinking, just to keep it easy on myself, I'm just going to throw the 7940X under dry ice. Which is lazy as hell, but it's just way, way easier. So dice the CPU, LN2 the GPU, and basically it means I don't have to do any real work. But yeah, definitely a fun card to bench. This is definitely like, I like this thermal paste. I definitely like this thermal paste. Though, yeah, it's kind of like, I definitely need to test both of them more. Both of these more. And, yeah, that's kind of it. So, the scores weren't exactly incredible. They did manage to bump me all the way from 59th to 58th in Extreme League, so I'm trying to work, Elite League. So I'm trying to work my way into top 50 for Elite. So one step closer to that, basically, because I was 59, now I'm 58. Oh yeah, and I wanted to get myself placed onto the 3D Mark Hall of Fame, except my UI version is too old. So I can't get put on the Hall of Fame, so I need to update my 3D Mark, and once I get LN2 again, I need to rerun this damn thing again. But hey, hopefully every time I rerun it, it gets a bit faster. Right? Because that's so far what it's kind of been doing, and it would be really neat if I figured out the software situation for this thing. Unfortunately, the 2080 Ti is coming out, so this is going to be kind of irrelevant. And I really would just like to keep benching this. I mean, I'd also like to bench the 2080 Ti, but I can't afford one of those, and I don't want to pay NVIDIA $1,200 for Pascal with ray tracing bolted on. I find that absolutely ridiculous. So, yeah, okay, that's actually it for the video. Thank you for watching. Like, share, subscribe. If you'd like to support what I do here with actually hardcore overclocking, like the abuse of, I don't know. I mean, it survived. Well, unfortunate, definitely unfortunate GPUs. Then I have a Patreon, I have a PayPal, there's t-shirts you can buy, and you can find a link to all of that down in the description below. And also, I need to thank alza.co.uk for sending the KPX, the Cryonaut, and right now they sell both of these, so if you want to buy these, you can buy them on alza.co.uk. And if you want to pick up LN2 pots from Kingpin Cooling, which the Tech 9, if you're considering NVIDIA cards that support the 8-point mounting hardware, I'm going to say you should definitely get one of these babies, because this does work really, really well. As much as I don't like the thermal performance of it, you can't deny that the 8 mounting hardware points are really, really good. It's just very slow. It's really a very slow LN2 pot, and you absolutely gotta glaze it, otherwise it's unbearable. But the 8-point mounting hardware is awesome. So, and it's also way cheaper than Der Bauer's things. So, you know, there's upsides and downsides to everything. So yeah, you can find all of that down. Like I'll drop a link to the Kingpin Cooling section of the Alza store, and if you're in Europe, you can pick up an LN2 pot from them as well as thermal paste for it. And I'd probably recommend that you actually like. You probably might want to start with this unless you're on something like AM3 Plus, where like the thermal paste doesn't crack and you can just roll with this anyway. So yeah, there. End of the video. Goodbye. Now where's the stop button? There it is.